Okay, so in this question, there's a set of 9 through 14 is a matching, A, B, C, D, E, F. So it's on page 133. And so one way you can do this is go to wolframalpha.com or use your graphing calculator if you have a graphing calculator. Okay, so I'm perfectly happy if that's the way you do this exercise, because it gives you some intuition and some experience. But the question is also, what techniques do they expect you to use to solve these problems? And they want you to use process of elimination. So here's some questions you can ask. Okay, is f of 0 equal to 0? Yes or no? So if you look down the list of possible functions, half of them this is true and half of them this is false. So you've right away already split the pile into two separate questions. That means there's three functions, and I'll let you figure out which ones they are. Three of the functions go through the origin, and those three functions have to match up with the numbers for the functions that don't have a numerical, like a number for the y-intercept. They just have, I'm just going to make up another question, like y is equal to x squared plus x, for example. That's a parabola, and it has, this is true, right? So then you're going to look for this point to be part of the graph. Okay, so that's one thing you can ask. Okay, what else can you ask? You can ask the question, is this a parabola, or is this a cubic, or is this higher order? So we're asking for degree of the polynomial. And this is a topic, this is what this chapter is talking about, is this degree of polynomial. So parabolas look like this, which is degree 2. So you're going to have things that look like, you know, if it's upside down, you're going to have something like this, minus 3x squared, blah, blah, blah. Or you're going to have, for this kind of shape, you're going to have like 1/2 x squared plus blah, 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 whatever. Okay? And please note the scales are different on these various plots, so don't assume that just because something's skinny, don't assume anything based on whether the thing looks skinny or not. Okay, so of these 6 plots, only one is a parabola. 2 of them are cubics. So the cubics look like this and this. So this is degree 3. So you're supposed to note that. This one is going to be like a positive, like 3 or 4 or whoever cares. Maybe it's a quarter, whatever, a third, I don't know. But it's going to be something times x cubed plus blah, blah, blah. Whereas this one is going to be minus some coefficient, blah, blah, blah. So you can right away tick off the parabola and the 2 cubics. And then you're left with 3 more plots. Okay? So we're really whittling down the options here. All right, so actually it's going to be pretty easy, because you're going to have one plot that looks like that and one plot that looks like that, roughly. Or, I don't know, it doesn't look exactly like that. There we go, something more like that. This is going to be a 4th degree, and this is also a 4th degree because of the number of humps. Every time you get one more turnaround, so this is a line, this is a parabola, this is a cubic, that's a 4th degree polynomial, that's going to be like a 5th degree polynomial. Okay? So these two you can determine which is which, because again this has a negative coefficient on it and this has a positive. How do you know that? Well, you look that the final trajectory of this plot is downward. The final trajectory of this plot is upward. So this has to have a positive coefficient on the highest term, and this one has to have a negative coefficient on the highest term. Great. That only leaves one possible plot, and that one kind of looks like that. And this is just going to be some number, some positive value, times x to the 5th, and then lower order terms. Okay? So those hints should help you Again, if you want to just plot them on Wolfram Alpha, the time is well spent. I want you to just explore and get to know these things. Okay, so questions 19 through 26. Leading coefficient test. They want you to figure out what the right-hand and left-hand behavior is. And so here's the possibilities. If you have an even leading coefficient, or if you have an odd leading coefficient, the behavior of these polynomials is really, really predictable, and they're not asking about what it does in the middle. So it's going to be, if the highest term looks like plus, you're going to have this kind of shape. Like an example will be x squared. Okay? So stuff can happen in the middle, who cares, but the tails have to both go up. And a good example of this would be minus x squared. Again, they can do whatever it wants in the middle, but the tails both have to go down. Okay, what if it's x to an odd power? Then it could have a positive or negative in front. It will look something like this. Okay, so in this case, you're going to have, who cares what's happening in the middle, but the final behavior is what we're talking about. So these are the only 4 possibilities. And so all you have to do for these questions, number 19 through 26, is to figure out which of these 4 cases we're talking about. Okay, that's all it's asking. Pretty simple. Okay, so what about these questions? 35 to 40. Finding real zeros of a polynomial. Okay, I just want you to, it just means factor. Let me just scan them and make sure these are all ones I expect you to know how to do. Yep, you can use the quadratic formula for these if you get stuck. Yes, and they're all squares. So I don't expect you to do the higher order ones, which the book expects you to do. I don't expect you to do. I just expect you to be able to either factor or use the quadratic formula. Again, these are things you can go to Wolfram Alpha to double check. Okay, number 98. Okay, this one I'll just show you how to do. This is a hard question. You're supposed to construct an open box with locking tabs. So the point is the total box. This is a weird box. This is not a super standard box question. But if the whole box, the whole sheet of metal was originally 24, the new bottom of the box is going to be 24 minus 4x in this direction, and it's going to be, you have to look at the book to see what I'm talking about, is 24 minus 2x in the other direction. It's kind of like making a pizza box is what it's doing. Okay, and then the height is equal to x. So the area is equal to x times 24 minus 4x times 24 minus 2x. Determine the domain of the function v. It means x can go from, it can't go from 0, but anything positive. If it's very, very small, then if x equals 0, it means area equals 0. So it can't be 0, but it can be very, very small. It can be a very thin pizza box. Up to x equals, okay, so this is the one that's going to cause the problem first. 24 minus 4x equals 0. up to x equals not quite 6. Okay? So we expect the maximum to be somewhere in the middle, so maybe x is 4 or 2 or something in the middle. Somewhere between 2 and 4 is where the maximum should probably occur for volume. So for this question, you can skip part C if you want. Sketch a graph of the function, estimate the value of x for which v is maximum. But if you want to do part C, I would just do this on a computer. Volume max on Wolfram. Okay, maybe I'll just show you how to type that in, and then you can play with that. Okay, so I'm going to just go over to Wolfram and see. X times 24 minus 4x times 24 minus 2x. What about if x equals 10? Oh, there you go. Okay, so they actually plotted this. This is the volume, and this is exactly what we said. It has to go from 0 to 6. Those are important points so that they're read. And let's just plot this. X equals 0 to 6. Then we don't have to just mess around. Oh, well, I don't know. Wolfram is being stupid here. Maybe I need to say plot. There we go. All right. So what you have to do is just look here and say, this is occurring approximately at where? That's the maximum volume. So just estimate, this is like roughly 2.5 or 2.6 or something like that. Okay? Right. So that's totally fine. That takes care of that homework question.